So yesterday we started section 7.4 and we were condensing using our 3 log properties. Today we're going to do the opposite. We're going to expand them. So we're still using the same properties. The first one says that if we have the log of a product, we simply add the 2 individual logs together. The second one says if we have the log of a quotient, we are subtracting the 2 logs. And the third one says if we have the log of something to a power, that power can be moved out front and we multiply it to the log of m. So as I said, we're going to use those same rules, but we are going to be expanding our logs today. The first thing to do is if you have a power, make sure you know that that power is going to be moved to the front. And you have to be careful because if it's only a power of part of the expression, you don't want to move it out first. All right, we'd have to separate the pieces. Any product or quotient is going to be separated into addition and subtraction. So when I look at the first example here, I see a product, the 4 and the y are being multiplied, but I also see division. So I'm going to pull this apart in 2 steps here. The first one, I'm going to split up this division. It's going to become the log of 4y minus the log of x. When you expand, each piece is going to have a log expression on it. Then I can expand the product, the 4 times y, and split that up into the log of 4 plus the log of y, and then minus that extra log of x that we had from the first step. And that's completely expanded. There are no powers to deal with. In this next one, we have a power here, but it only applies to the x. So I'm going to wait to separate that power from the x until I've split up this division. So I'm going to write log base 9 of x to the 4th minus the log base 9 of 81. Okay? Now powers can be moved out front, so this becomes 4 times the log base 9 of x. And then here I have log base 9 of 81, but 81 is a power of 9. We can think of this as 9 squared, and since our bases match, our answer here would just be our power. So we can simplify that whole log base 9 of 81 down to just a plain 2. Our third example, we have both a product, the 9 is getting multiplied to the variable piece, and we also have this power. But the power only applies to x, so I have to pull apart the 9 and the x before I can deal with the power. So I have log base 3 of 9, multiplication turns into addition, so log plus log base 3 of x to the 5th. And just like on the last one, I can simplify this because 9 is a power of 3. 3 to what power gets us a 9 would just be a 2. And then here I have this power of 5 that I'm going to move to the front, and it becomes 5 times the log base 3 of x. All right, for the next example, we have log base 5 of 250 divided by 37. So I'm going to split up the division here, separate this into log base 5 of 250 minus log base 5 of 37. Now 250 is not a power of 5, but it does have a power of 5 as a factor. So if we think of this 250 as just 125 times 2, we can actually simplify this down a little bit more. Because now we have a product here that we can separate into addition. So log base 5 of 125 plus log base 5 of 2 minus log base 5 of 37. And then this piece here, we can figure out 5 to what power should get us 125? Our answer would just be a 3. So we have 3 plus log base 5 of 2 minus log base 5 of 37. Now notice I never simplified log base 5 of 37 because 37 doesn't have any factors that are powers of 5. All right, for the last example on this page, we have a product here, we have a product here, and we have a square root, which actually can be thought of as a power. So we have log base 4 of 16 plus log base 4 of x plus log base 4 of the square root of y. Okay, so I separated all of those products into addition. Now I simplify. Log base 4 of 16, so 4 to what power gets us a 16 would just be a 2. Log base 4 of x we can't figure out until we know what x is. And then for the last piece, the square root of y is really the same as saying y to the 1/2. And we know that powers have to be moved into the front. So our final answer here would be 2 plus log base 4 of x plus 1/2 log base 4 of y. All right, to lead into our next concept, let's review some of the things we did in section 7.3a. We talked about doing that little loop. So 6 to what power gets us 216? If you look at your power chart, 216 is a power of 6. It is 6 to the 3rd power. So 6 to what power gets us 6 cubed? Our unknown power would have to be a 3. Here we have 100 to some power getting us 10. And remember, when we take a big number and are trying to get to a smaller number, like 100, we're trying to turn it into a 10, we're going to actually have to take some kind of root. So we need to square root this to turn 100 into 10, and the power for a square root is a 1/2. So x would have to be 1/2. For the last one, we have 1/4 to some power should get us a 16. Well, let's think about this. To get from 4 to 16, we square it. But to get from 1/4 to a 16, we also have to flip it over. We have to take its reciprocal. So a reciprocal means a negative power, and we are squaring it. So our unknown power would have to be a -2. But what if we have an example where we can't rewrite it using a common base? So like if I had given you this question, log base 6 of 217. Well, 217 is not a perfect power of 6. 216 is, but 217 isn't. So we have something called a change of base formula that we can use. Our log key on our calculator is using log base 10, called common log. So we can use a common log instead of log base 5, log base whatever. We can convert it using this change of base formula. So the log base b of m can be written as log of m divided by log of b using a different base. The only restriction is that your bases can't be 1. So we could write this as log base 10 of m and log base 10 of b. We can pick other bases for our logs as well, depending on the calculator you have. You have some options, but base 10 is going to be our easiest one since our calculators always have a log key on them. So log base 81 of 27, we can think of that as log base 10 of 27 divided by log base 10 of 81. You don't even have to put the base 10 in there because if we write log, that implies base 10. So grab your calculators. You're going to type in log of 27 divided by log of 81. Your log key is over on the far left column. And I do want to remind you that when you type log, it's going to start you with a parenthesis. You need to close that parenthesis off before you divide by the second one. Okay? So take a second, log of 27 divided by log of 81. We should end up with 0.75. But make sure you know how to check that you know how to do that on your calculator. Okay, next one, log base 5 of 36. Instead, we're going to do common log of 36, so base 10, divided by the common log of 5. Again, close off your parentheses, and we should get 2.2266. All right, go ahead and pause the video and try the last one. Okay, hopefully you typed in the log of 81, common log of 18 divided by common log of 4. And your answer there should be 2.0850. It's very typical when you're given a question like this that you go out to 4 decimals. It's kind of our standard way of doing logs. All right, our last example, it says the pH of a substance equals negative or the opposite of the log of the hydrogen concentration ions. The log of the concentration of hydrogen ions. So H plus represents the concentration of our hydrogen. So H plus with a little a at the bottom just stands for the household ammonia concentration. So for ammonia, our H plus value is 10 to the negative 11. For vinegar, our H plus concentration is 6.3 times 10 to the negative 3. We want to find the difference of the pH levels. And we said here that pH is equal to the opposite of the log of that concentration. So our pH for ammonia is going to be negative times the log of 10 to the negative, whoa, something happened to my board here. So negative log of 10 to the negative 11. So grab your calculators, type in the opposite of the log base 10 of 10 to the negative 11. Actually, you don't even need a calculator for this one. Since our bases are the same, this part is just going to be negative 11. The opposite of that would be positive 11. For vinegar, though, since we have that 6.3 in there, we're not going to be able to do this by hand. Our pH would be the opposite of the log of 6.3 times 10 to the negative 3. So go ahead and type that in your calculator, and then turn the video back on when you have your answer. All right, so we should get a pH here of 2.2007. And then it asked for the difference in the pH levels between ammonia and vinegar. So we would take 11 minus 2.2007, and our difference would be 8.7993. All right, so you are going to be working on expanding logs and using those expanding rules to evaluate. And also work on that change of base formula. Let me know if you need help.